Okay, let's find the vertical asymptote of this graph. See if we have one, two, maybe none. But we're given a rational function. Finding vertical asymptotes really goes hand in hand with finding the domain. So the domain, we don't want to plug in any values that would make our denominator equal 0. So let's see if we can factor the denominator to begin with. I think this is going to factor, but let's give it a shot. That the 2 out in front, we can split that up as 2 and 1. And then the x squared at the end, we have to make that x and x. Now this is a little bit confusing because it's a negative x squared, so maybe not the most common that you've seen this, not quite the same way you've seen this in the past. What you want to be careful of, and you could do the AC method or any other method to help you out on this, but I'm going to focus on my outer is going to be 2 times x, and the inner is just going to be 1x. Well, I want these to add together and make a negative. So I'm going to make sure that the negative 2x and positive 1x from the middle combine together to make this negative x. So that's how we could factor the denominator. Now, we don't want to plug in any values for our domain that would make the denominator be 0. So just kind of looking factor by factor, if I plugged in a negative 2 for this x, it would make this factor equal 0. So let's leave that out of our domain. And then if I plugged in a positive 1 for this factor, it would make that factor equal 0. Therefore, the entire denominator be 0. Okay, we could write this up if we're asked to with interval notation from negative infinity to 2. Leave out 2, or negative 2, negative 2 to 1. Again, open brackets or parentheses on both sides to leave those out. And then 1 to infinity would be the domain. Now, I said that these are very similar to our vertical asymptote question. It's very similar in that these values are either going to be vertical asymptotes or they're going to be holes in our graph, removable discontinuities. Now, how you could test that is you could factor the numerator and see if there is a common factor between numerator and denominator that you could reduce down and put into lowest terms by canceling out, basically. On this one, though, looking at our numerator, I don't see an obvious way to check that, to factor it. So what we can do instead to check these values of x is we can plug them in. We can plug them in and replace the x in the numerator. If they make both the denominator equal 0 and the numerator equal 0, they'd be a removable discontinuity. So let's test some values. So the first one is x equals negative 2. Let's plug this into the numerator, 5 plus 2 times negative 2 squared. And what we're doing is we're testing to see if this equals 0. So this is 5 plus 2 times 4, or 5 plus 8 is 13. The important thing, though, is it's not equal 0. So that means that x equals negative 2 is going to be a vertical asymptote, not a removable discontinuity. Let's also test our 1. So we have 5 plus 2 times 1 squared, which is 5 plus 2 times 1, or 5 plus 2 equals 7. All we really care about, though, is it's not equal to 0. So we get an additional vertical asymptote at x equals 1. So 2 vertical asymptotes, 2 points left, or 2 x values left out of our domain. Hope this helps clear it up. Next up, we'll be talking about when we actually do get removable discontinuities, how to locate those a little bit more.